Hello everyone. In this video, we'll explore a new feature in LuBan. It's called Conic Cut. It is under Mesh Cut function. So let's create a 3D model first. I'm going to create a sphere. Okay, this is our model, and we are going to cut this model by Conic Cut. Conic Cut is under Mesh Cut. I'll select the unit millimeter. Previously, we have 4 cutting methods: planar cut, grid cut, radial cut, modular cut, and now we have a new one. It's called conic cut. Basically, it's cutting the model by a coin, and the C, center, D direction is for the position of the coin, X, Y, Z, and the direction of the coin. You can also change the diameter of the 2 faces of the coin, end faces of the coin, and the height of the coin. The coin is indicated by the cyan model. If it's not that clear what the coin looks like, because it's hidden by the spherical model, currently you can click Object, Select. Use this tool to highlight the coin. So the coin is currently embedded, placed mostly inside the sphere. Therefore, we cannot see it. We can use the center X, Y, Z to change the position of the coin. So I can change it, move it. Let me exit the selection tool. So I can move it in X, Y, and Z directions. Okay. And this DXYZ is for changing the orientation, the direction of the coin. So let me make it facing the sphere. Diameter 1 is 5. Diameter 2, I'll change it to 5. If the 2 diameters are the same, then you will get a cylinder. Okay. If it's not the same, it is a coin. And we also have a parameter to set the height of the coin, the length of the coin. I'll set it to 20. So once I set it to 20, it intersects with the sphere. So it goes into the sphere by a small amount. I'm going to change it so that it goes in a bit more. Okay. And when you hit cut, the sphere model will be cut by the coin. And as you notice, we don't have the connector setting. If you use other cutting methods, such as planar cut, you will see a section of the connector setting. In the coin cutting, we do not have this option because the coin is some kind of a connector. Maybe the coin is the one that we are going to remove from the model. So we do not have the connector setting page. We hit cut and select an export folder. And this is the cut results. It will only have one part. It will not have 2 parts. So it will be the original model with the coin, part of the coin removed from the model. If the coin has no intersection with the original model, then the cutting results is the original model without any change. What is the use application of this method, conic cut? Usually, let me close this window. Usually we have designed something for little fan or for a box. We want to create a small hole in the little fan or in the box so that we can put some LED, we can put some wiring into the enclosure. And we can use conic cut to generate such a hole. Here is an example. I'm going to use little fan, balloon little fan. Many users have tried balloon little fan and they really like the function, except that the balloon little fan does not generate holes on the edge of the balloon. And this is what I'm talking about. I have a balloon little fan in the shape of a star, and I'm going to load a picture. Okay, maybe we set the border to 0. Okay, this is a typical balloon little fan. Okay, in order to illuminate the little fan, you have to put some light, LED light, in the balloon. So this is hollow. Once there is LED light in the balloon, and maybe even some battery, when you illuminate it, the little fan will light up. Previously, we do not have a good method to insert a hole, so our users have to use Mesh Mixer or similar software to generate a hole at the bottom or at the top. Now we have conic cut method. So we go to conic cut. Okay, this is the coin. It's a little bit too big, so I'm going to set it to 3 and 3. Then I'll set the direction to perpendicular to z-axis. Oh, this will change in this way. Okay. Yeah, maybe I'll put a hole on this edge. Wait, like this. Yeah, maybe a bit like this, and then I'll move it down. Yes. Okay. Maybe I'll put it somewhere here. Okay. Currently, the diameter is still too big. Actually, we can cut like this, but I prefer to have a smaller hole. So I'll set this to 2. And then slightly adjust y-axis to make the hole in the middle of the little fan. And before I actually cut it, I will check. I want to check if the coin is actually intersecting. It's a bit too long, so let's set it to 10. Okay. Now it's properly intersecting with the balloon little fan. So let's click as cut and put it on the desktop. Takes a little while to cut because the balloon little fan is a dense high polygon model. Okay, still working on it. I should have checked. Okay, it's done. Okay, now this is our balloon little fan model. As you can see, we have a beautiful holes for inserting the LED light, etc. Since the tool is in LuBan itself, it is very convenient for you to use this tool without having to resort to other software. And let's quickly check if there is any defect. So hole fill is a method to check if it has defects, simple defects. It can't check complex defects, but simple ones it can do. Still takes a little while to calculate. No holes, so there is no defect. And we can open the cut model, conic cut, part 1. And that is the STL generated. You can put this STL to the slicer for printing. and you should have a hole at the bottom. That is all. I wanted to show another example with the box, so we can put a hole on the side of the box, but it's straightforward to do. I believe it is straightforward to do after you follow the video of this example, so I won't do it in this video. Thank you for your attention.